This has been a long time coming. It's been a lot of time. I'm happy to have us all back in the room. A little bit about how today is going to go before I hand it off to the rest of the group, just because I'm going to be the last one on the mic. We have 3 presenters. We have some information to come from the folks at TriMech and from Stephanie with the SolidWorks user group. Then the presenters are going to go. We're going to hold our questions. A lot of you have already been mingling while we had a little bit of a delay. We're going to hold our questions until the end so you can do it in person, communicate together while things are happening. If you haven't already put the headset on and see the first person view of a drone race, please do that. Talk with Jonathan and the team about the Battlebots and what they're doing. And then the NYC FIRST team, they're going to be functioning and moving. You're doing stuff, right? Cool. So we'll get that fired up at the end after the presentations and community announcements. So that's a really big thing. There's a lot of shiny stuff. They've got the lights going. After the last presenter's done, if anybody wants to do community announcements, we'll make that happen first. So please kindly stay in your seats. We'll go through the community announcements and then we'll disperse to finish the pizza, look at the things. Yeah? All right. Since the slides are out of order, what do we have next? Stephanie.
Hello, everyone. Welcome. Thank you so much for joining us today. I'm super excited to have hosting this event on robotics or competition. I am Stephanie. For those who don't know me, I manage the SolidWorks user group of New York City. And this is a community for networking and upskilling on CAD. So if you have any questions on CAD, you want to be better at it, and you want to reach out to others who have a lot of experience using the software for creating very cool products, including robotics. This is a great community that you can reach out to and connect and up level in skills. So we are very active in the area. We bring in a lot of high-level skills to present and talk about the community. If you're interested, you can join us. We have a meetup site where we can, we just publicize the events that we're happening and we're doing an event every given day. And yeah, get involved.
How many people are SolidWorks users? Raise your hand.
Okay, great.
Is that enough?
Test. So with that in mind, I also want to open the stage for TriMech, if they want to give a few words.
More importantly, what is TriMech? TriMech sponsored this today, so there's a big round of applause for these guys. Part of the team.
And the Solid Systems.
And Dassault. He's going to talk about that. As well as Dassault, the makers of SolidWorks, but this is our sole representative for both.
So I've never needed a microphone before. So, first, thank you so much, Jacob, Stephanie, for having us here. We're actually honored to be here and be a part of this event with you guys. So thank you for that. We are here to represent TriMech. TriMech is a partner to many of the companies here, not only in Newlab, but in the startup and accelerator incubator space.
Has anybody heard of TriMech yet? Okay, I know you have, right? So Newlab, besides, we're not just SolidWorks, right? So we are a lot of things. So we sell Dell computers. We are a project engineering group. So we take projects that will go on a napkin sketch. We actually have 30 mechanical and electrical engineers on staff that can actually help you take that product from your idea to a manufacturing floor to actually get that product out the door. Kevin may go, one comes tonight, but he had another obligation to talk further about that. We actually have 3D printing, we have staffing documentations, we have an added manufacturing group. What am I saying here?
So pretty much anything that you need from engineering, from ideation to production. So we help our clients get their products, make cheaper, fast products, get them to market faster, and help accelerate their business. So that's what we do. Anything engineering and product development. If you have any questions or any ideas or thoughts, or if there's any way we can help support you, please don't hesitate to reach out to Bradley, Craig, or myself. I'm Rich Rosno here tonight. So thank you so much.
Yeah, thank you. Thank you guys.
Thank you.
Just for fun to help the TriMech guys out. How many of you are in product development? Who's doing some engineering, building a thing? Who's got hardware? All you guys, come on, raise your hands. Right? All right. How many of you are working with TriMech? Well, I see a half a hand back there. All right. All right, there you go.
We have one thing, actually. We do have a success story
Okay.
right here in Newlab. Is that okay for? So, a success story that many of you may know.
Get it back on stage, though.
I'm sorry.
You have to get back on stage.
I have to get back up here? Thanks. Oh, you're trying to get me intimidated?
No, just the
now?
camera's on.
Oh, the camera's on. Oh, sorry. So, a success story. Wait, how many people out there?
I don't know.
So, a success story for is one of the Newlab clients, or Newlab members, I should say, Amagy. Anyone here from Amagy? You are, okay. So when we first started working with Amagy, I think there was about 4 employees and 1 CAD seat. And we've worked with them since from day one to now, and it's incredible to see and be part of helping them reach their goals and see all the amazing things that they're done. So we have a lot of heart here for Newlab and for our new partners and for Stephanie. So if there's any way we can help you, please don't hesitate to reach out. Thank you.
Thanks. All right, I'm gonna go backwards. All right, quick. I talked about the run of show, but I just want to make sure that everybody knows who's doing what, who's coming here. So first we're going to start with Kate and Talia. Where are you? Come on up. Kate and Talia from NYC FIRST, and then Jonathan, I think you're up after them. And then Andre from Drone Racing League will finish it off. That might be backwards, but we'll see. So without further ado, let's get started. You ready?
Yeah. All right. Can I use this? All right. Does this work?
Nope.
Nope.
Podium.
No. Okay. There we go. All right. Hi, everyone. Thank you, Jacob, Randy, Stephanie, all of you that made tonight happen. I am Kate Karageorgiou, Chief of Staff at NYC FIRST. My pronouns are she, her, hers, and I'm a proud member of our community because what really excites me so much about the work, which you'll see tonight demonstrated through the young people that we work with, is that we're really reimagining what high-quality STEM teaching and learning looks like in New York City with young people and creating pathways to keep our young people here in New York City thriving. So what is FIRST? FIRST stands for Inspiration and Recognition of Science and Technology. Dean Kamen, an inventor and entrepreneur known for creating devices like the Segway and the insulin pump, founded FIRST in 1989 with the goal of inspiring young people to pursue careers in STEM. Together with Woody Flowers, a prominent figure in the world of engineering, education, and eventually legacy of mentorship at FIRST, they started an organization with the aim to make STEM subjects exciting and accessible to young people, similar to how sports and other extracurricular activities attract students' attention. Woody Flowers also developed the concept of gracious professionalism, which emphasizes competing with integrity, respecting others, and striving for excellence without putting others down. So FIRST is a global organization, the largest international robotics competition organization for K-12 students from over 190 countries. NYC FIRST strives to get a robot into the hands of every young person in New York City that wants one. For over 20 years, NYC FIRST has inspired and empowered K-12 students from diverse communities across New York City each year to engage with STEM and robotics in meaningful and joyful ways. NYC FIRST is a separate nonprofit from FIRST. We're the program delivery partner of FIRST, but we do so much more than that, which we'll go into. So our young people are reimagining the future through robotics every single day, combining the technical skills of STEM with the imagination and creativity of the arts. We've reached 8,000 students a year, and we're growing. Participation in NYC FIRST programs is a path-changing experience for young people, developing a range of skills, from technical skills like programming and engineering, and professional skills like teamwork and presentation, and SEL skills like academic self-efficacy and social capital. Each year, our programs impact the lives of thousands of students, as I mentioned, and teachers. We do this through district-wide programs, robotics leagues, credit-bearing courses for high school students, teacher professional developments and workshops, industry engagement opportunities like mentoring and volunteer opportunities, all supported by our network of STEM centers, which you'll hear more about from my colleague Talia shortly. So, robotics leagues. They're designed to inspire students at different stages of their education. The league programs also feature yearly themes that provide a framework for the challenges. So this year's theme is going to be an ocean-inspired theme, where teams will use their STEM and collaboration skills to explore the life beneath the surface of the ocean. We operate 3 different leagues in New York City. First LEGO League Challenge, which is FLL, First Tech Challenge, and then the First Robotics Competition. And each of these are distinct in their own ways, as I mentioned, developing different skills. We have over 461 teams at the moment based in New York City, and that's a lot of teams. And we're growing, as I mentioned, in all 5 boroughs. Our STEM centers. What's unique in New York City is that we have a network of STEM centers, and we're building out the civic-wide infrastructure that broadens resources, delivers opportunity, and sets young people on pathways to success academically and professionally. And this vision is centered on this network of STEM centers, which is the library system of the 21st century. They centralize valuable resources, including computing and software, fabrication equipment, and expert staff and mentors. In 2017, we opened our first location on Roosevelt Island at Cornell Tech. And again, you'll hear more from Talia about all the magic they put up there. In 2019, we opened our second STEM center at the Washington Heights Public Library. And while this year marked another year of growth for NYC FIRST, we're particularly excited that we've set the stage now for even more significant growth, opening our first new STEM center in the Bronx and our first in Brooklyn. In several years, adding to these hubs of learning at Cornell Tech and Washington Heights. And as you know, since 2020, how important this is. I just want to clap it up because this is really great for access. And we are coming to Queens in 2025, which is my hometown. So woo-hoo, Queens. And as I said, our STEM centers have enabled us to bring robotics directly into classrooms at scale, working with teachers, specifically in School District 6, up in Washington Heights and Inwood, leading to a second district in District 3, Harlem and the Upper West Side, and now eventually into Brooklyn. Our district-wide programs, they bring robotics into the school day, working with teachers, grounding the visits into the STEM centers and to classrooms, and customizing goals so that they integrate well with curriculum. And these programs are potent because they cast a wide net, and I can tell you, as someone who went and through all the AP math courses, calculus C, physics B and C, if I had had a mentor, I think I would have actually gone into study engineering, which I say it's not too late, but it's really important that we cast a wide net because we want people to see themselves in these fields. And our year-end surveys show that these are casting a wide net. Teachers are saying that students, over 100% of teachers surveyed said students were interested in robotics outside of the classroom. So looking ahead as we grow, we're going to cross the threshold of 400 teams in New York City and be affiliated with over 250 schools across New York City. We're doubling the number of STEM centers from 2 to 4, as I mentioned, with our eyes set on Queens next year. And now we can serve up to 100 teachers, 8,000 students, and now going up to 10,000 students. So lots of impact that we're seeing. And we're also seeing in really great data from FIRST and Brandeis. So they led a study on FIRST alumni that shows positive impacts were evident for all student groups, regardless of race, gender, income, or community type. And it showed that FIRST alumni are 2 times more likely to show an increase in STEM-related attitudes and interests than comparison group students. And recently, we did a survey of the alumni who have taken our high school courses over the last few years since, say, 2017. And while we're still analyzing the results, initial findings suggest that our alumni really would like more work and work-based learning opportunities in New York City where they live and grow up. And so I'm just going to say it. Hire our alumni. They're phenomenal, because if you don't, Hillary will. And they're phenomenal. As I mentioned, you'll hear from them more about what's happening. So I'll pass the mic to my colleague, Talia.
Okay. Good evening. Hello, my name is Talia Steen. I'm a senior program manager for the STEM Center at Cornell Tech. I co-manage it with Dana, who's there. Hello. And Yoav is right now at the STEM Center managing the night shift. I've been a part of this family for the past 7 years. I've helped found it, and I couldn't be more prouder to be part of this community. It's really hard to choose what to display today, so there's just abundance. So I'm just going to fly through just kind of things we do displaying the students' work. I'm focusing on the credit-bearing classes, special needs class that we teach, and the internship program that was just phenomenal this summer. And then I'm going to talk about INT, who are here today. Make some noise, show yourselves, and we're going to have a demo. This is where I work, make them laugh. It's Isaiah. It's a hub of learning. We provide valuable STEM education, an experience of rigorous learning, but always filled with joy. We offer a range of programming from workshops, including computer science, digital and non-digital fabrication, mechanical engineering, electronics, sensors, you name it, we've got it. Resources include 3D printers, laser cutters, CNC, range of power tools, materials, and the stunning New York City views. During the afternoon hours, we're open to all students from all across the city, and our location focuses on FTC and FRC. They're laughing because it's their past. They've changed, they've grown. There he is. Okay. Next. So let's talk about the credit-bearing classes. We have a lot of those, one every day. This is Energy Tech. This is from 2 years ago, where every class, the first semester is FTC, First Technology Challenge, where they take on this competition and they need to go through multiple design cycles, and they land where they land. They learn 3D and 2D and electronics and building and coding, everything to make the robot work. This is a claw which was, they had to grab cones during this competition every year, different challenge. So they 3D printed this 2-layer claw and then and put some rubber band in between, then went to the next design iteration, and they 3D printed and had silicone for a mold, then went through another iteration and bought some silicone and then took it apart. And this is their stunning robot, which landed them the Innovation Award, and they made it all the way to the NYC FIRST Championships, the New York City FIRST Championships. We're also very lucky to be on the Cornell Tech campus, and we collaborate with people on the campus. Niti Paraka, who leads the lab at Cornell Tech, always invites us and just lets our students come in. And this was a workshop about mycelium, so it was just another method of fabrication and cutting edge. And we were using vacuum forming to make the molds, and then grew competition parts and grew it out of mycelium. Next, I'll focus on Legacy High School, which is a very special needs school, and they come to us for 2-hour classes. We take them through FTC the first semester, and they compete among everyone, among the titans of New York, and just amazing. Anyway, during the second semester, we choose a topic on which to focus on. Every time it's something else. Last year, they wanted to focus on 3D. So we focused on 3D. We started with making gummies just out of ready-made molds. And then we taught them how to design molds. So this is a positive in which next we 3D printed it, and then we casted silicone into it, and then they made some made 2-part molds, some made 1-part molds, and then we made chocolates, and they could use it as reusable molds to make chocolate. But focusing on one topic an entire semester had them actually absorb the content. And they made chocolate. Anyway, and then we'll highlight the summer internship program, which it's just so much happens in very little time. It's only a 6-week program, but everything is done there. So we had 22 interns in both locations. Our location had 18 students. We work with a summer youth employment program. We work with the industry scholar program, which all fund this. So we're very lucky because they pay for it and we train them and then they teach. This is our cohort. They were absolutely amazing. Some are here today. We do 2 weeks of rigorous training, professional development, prepare them for the workforce, and then a range of technical skills, laser cutting, 3D design, 2D design, and vinyl cutting, and CNC machining, powder coating, and so much more. Then we flip, then they are the ones who teach the teachers. We flip the script. And we had 2 sets of PDs, 4 days long each. The first one was just intro to robotics, they're all rookie team. The second one, okay, 5 minutes. The second one included also advanced. They learned everything from building the robot, programming the robot. They 3D designed, they 3D printed, they did laser cutting, and got to understand what their students are going to be taking on and to be able to support them in that journey. And then they competed in the end. It's just 4 days long, so we're very proud that they could move a robot. Like, some of them don't even come from the background. Then we had a summer bridge program that's 2 weeks, rising 9th graders from Gotham Tech, which is a school we also helped found. And it's 2 weeks long. These kids are going to go through high school together, so it really also helps build bonds between each other and have a slightly nicer entrance into high school. They also built the robot, programmed the robot, learned 3D design, 2D design, fabrication, and everything else. Okay, so, and then these interns, morning shift, there's these programs, the afternoon shift is open to everyone else. So they led workshops. Early, what's happening here? Software update, not the time. It's not. Good luck. Okay. So, Early did a flat it out workshop, 3D to 2D, laser cut it, rebuild it. Kausar did a pre-cut workshop that baking swag, iron-on material, made swag. Louisa made a dip it in plastic workshop. Beyond being extremely satisfying, also has huge benefits for friction and better grip. Danielle did a driving innovation workshop and just showed a fully fabricated 3D printed bot that he made with a lot of help of the team and Megan, and it was amazing. Carol, who is here, led a workshop about Linux. He is an incredible, incredible programmer. Backend especially is his focus. And then they also took on a bunch of projects because you need to improve the space. So we got some 3D printers, Bamboo New Ones 3, and they were spitting out filament all over the space. So they made buckets to hold it and to support the thing. And trophies, they made trophies for an off-season FRC competition. And this is Daniel's 3D printed robot, completely 3D printed. It's going to be CNC and in a future version. Again, Carol's check-in system. This is a project that they started working on last year, led by Yoav, and they did it also with an army of interns, and then they just continued working on it this year, and it's just brilliant. It's a check-in system. We use a card, and Early made a soldering iron holder that had all the soldering iron, more in order. Louisa organized our drawers, which were a giant mess, and I just can't explain the obsession she got into. And every single screw is in the right container. It's just beyond remarkable. Like every single part has its designated location to live. It's just insanely beautiful. Every motor is around. Brings joy. Nina made a beautiful sponsor wall, which everyone is 3D printed and holds in with magnets, and it's to honor donors. We also worked on a D13 project that it's like, how would you teach laser cutting for fourth grade? So you make a little robot that walks, and there'll be customization options, and this we hope that they'll do in fourth grade. We also collaborated with Cornell Tech. And then I'd like to just focus a second on these guys that are an incredible, incredible team, and it's a community team. It was born within our STEM center. They are all about giving access to every single student across the city. They are complete heart, and they have reached 5th in the region as a rookie team, which is beyond amazing. They made it all the way to Worlds by winning Rookie All-Star Award. They also won Imagery Award because their robot is so stunning. They homaged it as a freelancer to respect Yoav, who, again, I don't know if you'll see it, but he's in the STEM Center and he's an incredible mentor. Darius won the Dean List Award winner, which only 10 in the country win. And it basically says you're a rock star that shows up every single time and supports everyone around you. He taught programming to half the people here. He's also here. Darius, hold your hand. Employ all of them. Anyway, incredible team. Give them jobs. They're all here. They all want jobs. And volunteer for us.
And we'll leave it at that because we know we took up time. But please stay in touch with us. You can sign up for email updates, volunteer with us. We'll share out the slides as well after. Hire our alumni, lots of ways to stay connected, and come talk to us after. Thank you.
Thank you.
There we go. Hopefully everybody can hear me. It sounds good. First of all, amazing stuff that the NYC FIRST people are doing that I did not know a lot about, and really cool bringing access to a lot of people. Battlebots and Team Huge, a bit more personal, not so much of an organization as that, so we'll have a bit of a different tone to it, but my hope here is just to kind of explain a little bit of what Battlebots is, what combat robotics is, what we do with it, and then some of the things we've learned from doing it for a long time that maybe is something that can be a good takeaway or something to think about afterwards. First of all, hi, my name is Jonathan Schultz. I was one of the original founders of a team called Team Huge, which has been on the TV show Battlebots for a long time. I'm not the only person, we have a whole team, but I'm the one who's here with my girlfriend and teammate Maddie, who's over there with the robot still, keeping it safe. So, like I said, my name is Jonathan Schultz, but we have 7 other people on the team. We're spread across 4 states. We have competed for 5 different years of BattleBots, which was constituting 7 seasons of the TV show. We've been working on the design of that robot since 2016, but some of my teammates have been building robots since 2009, and we are lucky enough to have won the Best Design Award in our rookie season, which was World Championship 3, and then we won an award for the Most Destructive Robot in World Championship 7, as well as getting runner-up. So we have done a lot of robot competitions through the combat robotics world, and like I said, a lot of experience that we can kind of share from that. So to start with, meet the robot, meet the idea of what combat robotics and BattleBots is. This robot that we've brought and have over there is a 250-pound fighting robot. And combat robotics in general is competitions for people to build these robots from scratch in their homes and maker spaces, etc., in their schools, to fight each other. So there's weight classes beyond 250 pounds. There are a lot of more local competitions to fight smaller versions of the robots. But if you want to be on an international TV show, right now what you do is you have to build a really big one. So Huge is a 250-pound fighting robot. And as noted by the photos, our whole thing is that we are quite a bit larger than most of the other robots. So we have 40-inch wheels, 40-inch plastic flexible wheels, which kind of fit into our overall design idea. There's also a 36-inch spinning blade in the middle made to attack the opponent that spins at around 2,000 RPM or about 200 miles an hour. And then otherwise, there's a lot of design features to it. One I highlighted here is 6 independent electrical systems for redundancy, but if I talked about all of those features in the robot, we would be here for an hour. So if you have any questions, we will be with it afterwards. Absolutely, feel free to come ask. I included a list of materials just because I think it shows we use everything at our disposal, including, we in particular are a team that has uncovered other materials and brought them to the light of the BattleBots community. And what's fantastic about that is a lot of the BattleBots community and combat robotics community helps out with FIRST robotics teams. So we a lot of people mentor FIRST robotics teams, and what is fun is a material called Tegris that we helped bring to light in robotics. I was actually able to see in use in unique ways on FIRST robotics robots as well. And then that has helped give us some ideas back of how we're going to use it in Huge in the future. So the point of this slide is a short set of clips that hopefully kind of illustrate the general idea of what Huge does. So Huge is a completely unique robot that has gargantuan flexible plastic wheels and a big blade in the middle. So when we're fighting a much more normal, conventionally designed robot, we have a massive reach advantage and basically a totally different strategy. So we've embraced flexibility and basically defeating the opponent faster than they defeat us with a type of wheel design that can get eaten away eventually, but the intentions are that we win before they get the opportunity to totally defeat us. So we've fought dozens of times across all the weight classes. There are lots of videos on YouTube if you look up Huge, but I figured that this was the fastest way to kind of illustrate it. Huge is something that we've been iterating on for years and developing the idea of how we want to basically go at the competition aspect of it. But the advantages of being such a massive robot is that every person that you fight is hyper optimized to fight each other. They are all trying to be as small and as dense as possible. And this basically leaves a large opening that we can go through to exploit. Because we always say Huge is not a hard robot to beat, but you're going to lose to everybody else if you build something that's designed to kill it. This is a strategy that took a very long time for us to hone in on because it's completely unique, but it's something that has borne out very well for us. So we get the question a lot, why BattleBots? Why put all your time and effort into this? Why find sponsors and all that sort of thing? It comes from a lot of our passion for the competition and our passion for robotics. But I think that there's a lot of magic to combat robotics. Specifically, my favorite part of it is how the problem never changes, right? The problem since 1994 has been defeat the other robot. The changes are in how you choose to do that and what you've invented and come up with to be able to do that. And so I think that's such a magical thing, because it's Darwinism, right? Win or lose, if you win, you beat the other guy. If you lose, you lost, and you have improvements to make. One of my favorite stories about how that is that over the past couple of years, as 3D printing has become really popular, a lot of robots have become 3D printed out of rubber. And rubber is a super resilient material, especially when everybody is a kinetic weapon. So after the rubber robots took over and started winning everything, the clock turns forwards and the progression goes from there. Flamethrowers have been legal in combat robotics for a very long time without people placing too much focus on them. But as for anything that is 3D printed, it must do one thing at first, which is to melt. And so the flamethrowers have started to rise up to take on the rubber robots, because if you cannot defeat them with kinetic energy, we'll defeat them with heat. So I'm sure that this process will continue onwards, because it always does. When we were new, were part of this and created changes to the game, as many others do. But that's part of what keeps us going and drives us, is because we had designed Huges, this style of robot, for years to deal with kinetic energy and different types of stuff. And very recently, we had to completely redesign Huge from the ground up to make one designed to not melt, because I built my robot out of plastic. So it has fiberglass wheels, it has thin titanium heat shields across the entire frame, it's covered in heat reflective tape, and we've only fought one other flamethrower with it, but I am very happy to say that we did not melt. So I included across the bottom photos, which are a little blurred out from here, of every single iteration of Huge that we've had for Battlebot, the TV show. This ignores 11 other iterations that were not for Battlebot, the TV show, because we're very active in many different weight classes. But I think that that's kind of the great spirit of this, is you're always learning something even when you win. And these robots, as a design constraint for us, always look like Huge and always look the same, but each one is completely different, and I'm sure the earliest ones would get clobbered if they were to fight today. This is a very short slide. Like I said, I could go for hours of some of the changes that have been made over time, but just showing kind of the thought that goes into each part. On the left is our weapon motor module. Again, all this is in the robot, so you can come see it afterwards. The mountains that had to be moved to make that 1 inch thinner could not fit into PowerPoint, but all of that is in pursuit of more space inside the robot, weight savings, to continue to be more competitive. In the bottom right, WC3 represents World Championship 3. That was our earliest season, and that's the giant wheelchair motor that drove Huge around. It weighed 14.5 pounds. On the right next to that is what we currently use. It weighs 7.5 pounds. Like I said, all new electronics, all new control schemes, learning new stuff, implementing that into the robot. It's assembly that has aluminum machine parts, plastic machine parts, carbon fiber parts. It's every little step just to find that edge, because our weapon blade is 35 pounds. If I can make the drive 15 pounds lighter, I can do something with that. And then otherwise, the geometry of our weapon blade is in the top right, and it's something we're most proud of, but it's something that is a constant iterative improvement, because when you are a totally unique robot, we need to make the most of any hit that we get. Those types of new designs, it's very inside baseball, but that is how we do that. It is SolidWorks. Yeah! Yes. We have used SolidWorks for every CAD of every Huge that we've ever made, and from the beginning, they've been somebody who's worked with us, and we're very appreciative. So I think I said 15 or 16 different iterations of Huge. They all exist as a ground-up redesign. Generally, the parts are unique. We're making new stuff, but that is, the march of iteration moving forwards. So, on top of that, me talking about how much I like combat robotics and how much I think it benefits us to learn these things, and me as an engineer to learn these things, I can also talk about how being a completely unique design has so many benefits. I can't even express how rewarding it is to see something completely unique and mind-blowing win a single fight, compared to the joy comes from winning an entire event when you ripped off somebody else's design or copied something else. So, personally, when I started building combat robotics, it was for my senior design project from college for my engineering degree. And given that it was one semester, I was alone, and it was the first time I ever did it, I did one thing the most, which was copy what other people were doing, because I needed to get the project done. Building that robot taught me how much higher the mountain was than I thought it was once I saw other people's robots and how well executed everything was. So to me, what made it so interesting was to be able to chase a unique design instead. it was a shinier object. So being able to hone Huge over the last 10 years, it was still something that took iteration to get there, but I just had so much more fun doing it, and the changes that have come to the competitions from being able to think in these different ways have influenced a lot of robots. So in my mind, I feel like I've learned more than just trying to copy somebody else's homework, for better and for worse, because it is tough when you are the only person doing something. You do kind of have to figure it all out yourself. Otherwise, I will note at the bottom, we did win the design award, which is voted by the other builders, so it helps to impress them and show them something they haven't seen before. If you look at all of the Battlebot robots that have ever won the design award, a lot of them are beautifully machined and precision made. And then there's one in the middle with some hand-cut wheels that's really big and with some angry eyes on the front, because it was enough of an out there idea that the builders loved it. And to show our growth, the most destructive award was won 5 years later, and I like to think that the design award was a reflection of the idea, and the destructive award was a reflection of execution. Because what we learned in our earliest seasons of BattleBots is that we still had a lot to learn, and it took us years to get to that level. And one more slide. Finally, this is one of the things that I take a ton of pride in as well. I think that, as mentioned, the First Robotics folks, like, you guys provide a structure for kids in a way for them to really learn. But I love that being able to do BattleBots and put it in front of a giant audience can reach so many people and get people interested in robotics, because then I have somewhere to point them to, which I do constantly. So it's something that I think really hooks kids when they see it. And at least personally, when I was 5 years old and I saw BattleBots on TV, that was when I learned what an engineer was, when my parents, neither of whom are engineers, told me that this is the type of job that you get when you want to build the robots on TV. I didn't have a lot of trouble picking what major I wanted to be when I was going to college. I knew I wanted to be an engineer because I knew that this is what I wanted to do, and I try and keep that sort of thing in mind every time a kid walks up at a competition to look at the robot that we've worked on, or otherwise when I have the opportunity to bring it here. I've had little kids walk up to me before and say, "Can I help tighten the screws on your robot?" And I said, "Absolutely," and I let them work on it. I have lost fights because there were screws that were not tight enough from having a little kid. And the first time I ever did that, the little girl sneezed on my hand. So, but hand sanitizer exists for a reason. And I think that that's one of the most important things that I can do through this, is it's not just that I can have this passion, I can have this hobby, and I can enjoy it, and look at me, I'm great, I'm on TV. But being able to actually go out and mean something to a kid in the same way that just seeing BattleBots on TV meant to me, because I didn't even meet anybody doing this, I think it's really one of the magic parts of it. And my hope is that they kind of follow the pipeline, right? They go to school, they go through robotics classes, and once they are out of high school and really want to build their own robots again, they come fight me at BattleBots. So that is it. Thank you very much, everybody.
Let's see. All right. Hi, my name is Andre. I'm the Senior Vice President of Engineering for the Drone Racing League and the Infinite Reality. Drone Racing League is basically a sport that could not exist not so long ago. We're trying to basically mix the games or video games and the real world by building those kind of crazy fast drones and having best pilots in the world fly them and try to race each other and see who gets to the finish line first, or at all, because our course lines are not easy. They are three-dimensional, and it's a really cool challenge. When I first started the Drone Racing League, the first ever event I've been to, I thought those things they shouldn't exist, because basically I felt like I landed inside a video game, and everything around me was just like, I tried to touch, like, is this really real, what I'm seeing? But before I go on, let's take a little look. Hopefully it will get a bit of a sense what it feels like. How do you start this? One more click. All right.
Immersing fans with high-tech and high-speed competition across all dimensions. As the world's only global professional drone racing property, DRL enables pilots to compete in real life, esports, and even the metaverse. DRL has held more than 40 global events across iconic
At least one more
international
video
cities,
playing somewhere.
including cultural landmarks like palaces and stadiums, and real FPV. DRL's popular games let fans learn how to fly, race, earn rewards, and even compete with DRL pilot. At its core, DRL is a technology company, engineering and designing every piece of technology from the ground up that is patented, proven, and world record set. And DRL of all ages through the DRL Academy. Welcome to DRL, the sport that's made to win.
It's a bit of a cute video to set the tone. So DRL events is essentially the culmination of many weeks and months of very hard work of a team of engineers, of a team of operations people, and bringing up one of the events is really a phenomenal kind of achievement. Just for a little bit of a taste, it takes 12 53-foot trailers of equipment for each of the events. It takes us 4 days to build the entire scene with the lighting, with the effects, with everything. It ends up in 2 days of racing, so the actual thing for which we come. It takes about 250 people to make this happen, and we place 47 cameras all over the place. So think about like a typical show that is produced with, sometimes you have a single camera show, sometimes you have 2 camera shows, like for 2 angles. We have 47 cameras filming the event. We end up obviously producing an enormous amount of data. So we talk about 80 plus terabytes for one event. And we bring a huge fleet. So we bring 400 plus, usually it's between 400 and 600 drones like this one that we bring to the event. All of them are designed and made in New York City, by the way. We assemble them and make them inside of our office in Midtown, Manhattan. For a flight, we take 4,867 feet of a course length. Of course, it's not every course length will be this long, but some of them are actually longer than this. It's just one example. We represent multiple countries, so we take pilots from all over the world, and we actually race in different places in the world. So in this case, it will be 7 countries represented. Our typical race is 12 pilots that compete for one place to be the champion. And here's a peek at something that actually not many people have seen at all outside of the company, and that's what it looks like to build the event. So this is a bit of a time lapse. This is 4 days concatenated into a few short minutes. Slowly the lighting comes on, then the actual crowd. This is what the pilot sees. And just looking at this makes my heart race a little bit. By the way, after this, you are all welcome to come to our little table, and you can actually put the goggles on and see recordings from 2 of our different events, again, from the perspective of the pilot. So you'll see through the eyes of the drone. So world-class pilots really recruit only the top of the top to be the pilots. And honestly, it's not just because it sounds good, but also because these drones are extremely hard to control. So I don't know how many of you have tried flying a drone, but if you try, that's great. So like if you tried flying a drone like a DJI, the difference is vast because DJI drone is basically doing the flying for you. When you fly a DJI drone, or I'm using DJI just as an example, but any of the kind of typical drones, the drone basically is stabilized and will do everything for you. You only give it instructions. So you tell the drone, go up, go down, fly forward, fly left. You get the idea. This little guy basically has intentionally, it was intentionally designed to rely completely on controls of the pilot. Because what will happen if you try to race with a drone like a DJI, it will essentially resist you, because what it tries to do is always be as stable as possible. So if you try to take like a sharp corner, it will actually try to do something like this, because it tries to do a good recording, it tries to stay stable. This guy is exact opposite. You want to try as much of the maneuverability as you can squeeze out of this machine. So this thing puts through about 100 amps of current into the motors just to be able to get like ridiculous, crazy dynamics during the race. And therefore they are completely unstabilized. So to fly one of those, literally your fingers are the stabilizer. So it's up to the lightning reflexes of the pilots to actually operate them. So, forget racing. First thing, when I started working, first thing I was kind of told to try is to just hover this. So basically just lift off the ground and stay up for a little bit. It's so hard. It is, because the drone reacts to the most minuscule movement of the stick to immediately try to run away to the side, to the other side, to crash into something. So it's a lot of fun. After about 3 minutes of hovering the drone for the first time, I felt like I ran like a marathon. I was literally I just need to sit down. 6 pilots race at a time on the all race in the first person view. So it sounds a little bit like a no big deal, but actually it's the huge challenge that presented us with the need to build our own technology. There are a lot of hobby systems similar to this that can make fast drones that can race. However, making a coordinated effort with multiple drones up in the air, all of them streaming video in identical quality back to the pilots, is a big challenge. So the pilots all sit on the flight deck, basically in comfortable chairs, and they wear first-person view goggles, so essentially looking at the world through the eyes of the drone. Think kind of virtual reality minus the ability to look around. It just gives you, wherever the drone is looking, that's what you see. And all of the communication, all of the control is facilitated by a central system, a central radio control system that we have built. So essentially no radio signal passes between a pilot and a drone during the race. Everything goes centrally, first of all, from the pilot in a wired fashion to a central system, and from there is a central distribution with radio antennas that allow different drones to operate at the same time. We build those drones and design them in-house. This is not SolidWorks, but actually we do use SolidWorks. This is just a very comfortable example I had close by to make a snapshot. But yeah, we design the drones in-house. We constantly iterate, we constantly innovate, because as you obviously know from the world of hardware, you cannot stand in one place, right? You immediately go backwards. You have to constantly move forward because you have to improve, you have to fight obsolescence of components, so we constantly have to design and move forward. Making 600 units of the fleet is also a challenge because we need to make them identical. The idea is that it's a spec race, so all the pilots have to be competing with the same drone without having advantage over one another except for their personal skills. So we use our custom-made testing equipment and tuning equipment that we also design and make. Each drone has to pass through a series of tests and through a series of tunes before it can be considered flight-worthy. And even after that, we have to test each individual drone before the race because a lot of things can happen in transit. So you don't want to give the drone to a pilot ready to race in the World Championship just to discover that the antenna is a little bit unscrewed on the side, right? So, as well as PIDs, actually. I don't know how many of you know, but the drones obviously have multiple PID controllers. And it's a surprisingly complex challenge to tune them normally because it's a flying machine, right? It's wireless, and the PIDs are responsible for the motor response based on the stick movements that are also controlling the drone in a wireless fashion. So in a kind of hobby world, what happens is people just try to fly, the drone fails, and by the way it failed, they decide, okay, I want to bump up the P element or the D element of the PID for yaw, because it started spinning. We need to eliminate that because with 600 fleet, you cannot allow that kind of work. So we designed our own tuning system to actually take it down to science. So we take the drone into a special rig that allows it to be securely fastened and move in multiple, in all the axes basically. And then we tune the PIDs by measuring the output and deciding on the coefficients. So this is what it takes to build this drone. This is, by the way, a 4th generation of this drone. It's not, obviously not 1, 2, 3, 4. There is like 4.1, 4.2, etc. But this is, largely speaking, 4th generation. It takes 110 individual components to build this drone. Admittedly, a lot of them are screws, but it's still 110 components that need to be assembled. So from quick count, it takes 65,400 parts to build the full fleet. And of course, the full fleet also suffers a lot of damage and unfortunate accidents when people are using the drones. Which is, by the way, one of the things that crowd loves the most. Like, there's nothing better than seeing the drone literally explode into pieces when it hits something. The cheers from the crowd are enormous. Also, a small anecdote, when this, we had a race in Las Vegas a few years back. And when we left, so you see this little fin, the drone had so much kinetic energy, it embedded itself into the wall of the building from the collision, and we couldn't take it out. Like, we had to leave the little fin sticking out of the wall. So it's a lot of kinetic energy. So yeah, it takes additional 35,000 components just to maintain the fleet and keep it in the operational state. So custom design radios, I touched a bit on this before, but basically, initially, as a company, when we started, we tried to use, well, first, obviously, the hobby stuff, which is easy, it's off the shelf. It works, but it works on individual basis, which makes it very hard, and especially hard to make fair, because, hey, I moved a little bit to this corner, there's a null in the radio frequency pattern, and suddenly my drone doesn't work anymore. But this guy next to me is okay, so it's no longer a fair spec race. So we had to make sure everyone gets the same exact quality of the signal. The other thing we tried, obviously, is using closer to like 2.4 gig frequencies, and then obviously we discovered that a venue next door turned on Wi-Fi and our drones fell off the sky, which was unfortunate. I think that venue suffered some accident to their Wi-Fi router, but so I heard. So ultimately we came to making our own radio system, and the radio system that we built is very similar to what you would think of a cellular network. So basically we have a central station, we call it the DAS, the Distributed Antenna System, and it has a dual network, part of it for control, part of it for video. So control is bidirectional link and video is unidirectional. We receive the video from the drones. And this allows us a huge, huge flexibility. We can do essentially vast range of frequencies because we use kind of top-notch, at this point, kind of military-grade radio technology. So it allows us frequency agility. It allows us to do deployment of antennas in a different pattern. So think about complex venues like this one. If you wanted to cover this area, you can put one antenna, it's good. But what if you want to have a drone that flies outside? Suddenly it's not so good. So you need maybe a second antenna in the corridor and maybe a third one after the corner. So it allows us to decide how many antennas to use and how to deploy them. So we can easily cover stadiums, insides and outsides of stadiums. So we can have our races in this wild variety of kind of magical setting. It's really just up to the imagination. The last thing it gives us is safety. We're actually one of the only, or the only, FAA accredited drone sport, because we are able to demonstrate that we have protocols and systems to guarantee the safety of participants and employees during those events. This system has kind of a global kill switch. It has a global arm-disarm switch. So as long as the central controller operator does not flip the switch, no drone can take off or even start. So basically the controllers are powerless until a global switch is flipped. So this is a big deal because that switch can also flip backwards, right? So if any drone deviates from the flight path or behaves in a way that is undesirable or unpredictable, there is always a person on the controls who can just, with a flip of a switch, take all of the drones from the air at the same time. We are always in a constant, like in R&D mode. We always look at new technologies. We always look at innovation. Therefore, we always, well, I always try to hire the best team to keep around, that we constantly can find new ways to improve the sport and to improve things that we do in general. We always research new ways to improve the radios, because our radio is pretty amazing, but it's not flawless for sure. So we always try to improve that. Obviously looking for new materials and new ways to make the drone more resilient, more lightweight, more maneuverable. Sensors, I spoke a lot about the drone itself, but actually there is more to that, because how do we know who's winning, right? So we actually developed our own timing and scoring system. So our drones and gates have matching sensors. So when the drone flies, we have a way to determine waypoints that the drone passes in real time, which actually is then transmitted from the drone to the central station, and then from central station to the timing system, and the timing system eventually talks to a scoring system that tells how is competition going, right? Timing tells, hey, this guy passed gate number 2, but the scoring system says, oh, this pilot is now in the second place in the race. So we are building also a lot of supplemental systems. Scoring is actually not trivial. Scoring is not trivial, but I meant to say timing. Timing is actually not trivial because those drones fly 60 to 90 miles per hour. So at that speed, it's not very easy to determine. And again, three-dimensional race. So remember that a drone flying like this or flying like this, it's not the same thing. So if you put a sensor here, it's not necessarily going to read it if it's upside down. And drone is often upside down because they would do like a maneuver. So very interesting stuff. A lot of R&D and constant R&D. It's a key to kind of staying ahead and keeping the league more interesting to the viewers. But, you know, having this cool team of engineers means we can do more cool stuff than just race. So we take on special projects that our partners or sponsors like for us to execute. So I bring a few just basic examples of, or prominent examples. T-Mobile, a very good friend, they came to us and asked us to, can you do this little thing? Can you build a drone that is a racing drone, but it also operates on 5G network? I said, sure, why not? Let's try. And yeah, and about a year later, we had a first ever racing drone to actually operate on the 5G network. And the challenge in something like this is, remember, this drone is not stabilized. So how do you send a signal that's fast enough over the 5G network that has low enough latency to allow a pilot to actually stabilize a drone midair? That was one of the most interesting projects because it involved so many aspects, from understanding completely new space for us, the cellular 5G networking, working with a really cool partner like T-Mobile, and at the same time kind of rediscovering things that drone does or doesn't do when we want it. So that's one interesting project. Another one is Lockheed Martin, this little startup company, came to us and asked if we could do this little thing. You know those drones, those racing drones, can you just make them fly on their own? We really like it. And said, why not? Let's try. And we made this, we called it the Air. It's basically autonomous robotics challenge to make an AI-powered drone. So we built this drone that looks not at all intimidating on the left. It looks very small here. It actually weighs so much. First time that I tried to pick it up, I was completely amazed that this thing can actually fly. Like it's just like this podium would start flying for all of a sudden. And we took the challenge to multiple universities and AI teams, PhD students usually with mentors, and we gave them a challenge. Okay, we'll give you a platform that has computational power sufficient for AI processing, a lot of sensors and cameras on the drone. We give you this simulation environment, which honestly I haven't touched in this presentation at all, but as a byproduct, we also build a game with a physics engine of our own and a simulation for the drones. And we'll give you this, and you train algorithms and make them fly and race, and eventually the best team that races and actually challenges a real-life pilot will win. And that was one. And the last, really like a tiny one, is we just broke and held for many years a Guinness World Record for the fastest drone. And that's the little guy there, the Racer X. Sadly, our record was broken, I think, last year, and we are kind of working to take it back. And that's it. Thank you.
Thank you, everybody. Can we do one more round of applause for the whole of the audience? I just have to reiterate to where I said from the beginning, we're here to promote and support the robotics ecosystem. One of the things that I think is really most important is when you talk about robotics or hardware in general in New York, people don't think it's a real thing because it's too expensive. There's no space. It doesn't happen. But we just heard about the Drone Racing League manufacturing all of their drones in Manhattan. The NYC FIRST building the future of the roboticists in this group that are someday going to compete against Jonathan, right? All right. Before we stand up and get back to doing demos and talking community announcements, if anybody wants to do a community announcement, I'm going to we'll leave the microphone up here, get in line up the stairs, give you 20 seconds, give or take, to walk through. Tell us who you are, if you're looking for a job, if you're looking to hire people, what you need, what you want. If you just want friends, or if you want to go walk your dog with somebody, by all means, whatever you want, now's the time. All right? Line up here. Nate's first. I know that he wants to do it. Or Alex. Hurry. We're good.
Hi, my name's Alex Weiner. I'm a roboticist. I know pretty much any programming language you could think of off the top of your head. I'm looking for work. I've worked at some big name robotics companies